Dimensional analysis is absolutely one of the most important things you can learn to be successful in introductory chemistry. So I'm going to walk you through it. I'm going to break it down and make it understandable. And you're going to be able to do math in your chemistry class, in your physics class, and in your other classes where you have to convert units like you've never been able to do it before. So let's walk through this. Now, the question is, what is dimensional analysis? Well, it's our math tool to be able to convert units. And a big part of chemistry is converting units. If you stick with me on these series of videos, we'll get there. But it's going to take a little bit of learning before we do. And I'll remind you down here at the bottom that this is the most important math tool that you can learn as you're starting to learn chemistry. We'll be able to answer questions like how many grams in 100 kilograms, just converting those units in metrics, or how many molecules in 100 grams of sodium hydroxide. Now, you might be thinking, I don't even know what any, that's okay if you don't know what it is. That's actually what we're going to learn as we move along in our courses together here. But even things like how fast does light travel, converting those units, and everyday things like how many pieces of pizza do I need for my friend's birthday party if they're each going to eat 3 slices, and I think 8 of my friends are. That's dimensional analysis. That's converting units. Now, after 15 years of teaching this topic, I've boiled it down to 3 rules or 3 steps that will get you through any dimensional analysis problem. So if I was you, I'd take a moment, pause the video, write this down. If I have a box on something in my presentation or in my lecture, my students know that this is something they're going to need the entire year. It's super important. So I would encourage you to write this down. Pause it. The rest of us, we're going to keep moving forward. Now, let me explain a couple things about my rules or my steps. The first one is, what are these conversions that I'm talking about over here? Conversions are anything where you have a relationship between 2 objects or measurements. There is definitely a relationship between 60 seconds and 1 minute. And there's lots of ways to write this, but the way we need to write it to have a conversion is 60 seconds is equivalent to or is equal to or has a relationship with 1 minute. So this is a conversion that we've turned into a different format that's going to be useful for dimensional analysis. Now let me show you something that's also going to be really powerful. Because these aren't just numbers, these are measurements, these are objects, we know that 1 minute is equal to 60 seconds. In fact, these are all equal conversions. Now, let me show you. Any math teacher is going to totally lose their mind if you tell them 60 over 1 is equal to 1 over 60, because those two are not equal. They're not equal because, well, those are numbers, right? 60 over 1 and 1 over 60, they are not equal. So why is this equal? Because these aren't numbers. These are measurements. These are units. 60 seconds per 1 minute is the same as 1 minute per 60 seconds. That's going to be hugely powerful as we work our way through this. Another one, maybe we're converting between miles and feet. So we would write out 5,280 feet is 1 mile. And maybe we needed, because these conversion factors are going to help us solve problems, maybe we needed this to look the other way and have like miles on the top and feet on the bottom. We can do that. And I'll walk you through this as we learn more and more about dimensional analysis. And you'll see these are the conversion things I need. In fact, we're going to get into some wild stuff that you probably don't know about yet, like converting between moles and atoms and molar mass and all the really important things we need to know to be able to do chemistry. Then what does it mean to write down what you know and cancel the units, which is what I have over here? That's a really tricky one to explain in words, so I kind of think it's easiest to just do this as an example together. Here's our first one. Now, bear with me, because some of you might know the actual answer to this right off the top of your head, but the point is not to know the answer. The point is to use dimensional analysis to come to some conclusion. So my goal here is to show you the process of dimensional analysis with something that's fairly simple. First thing we do, we write down what we know. If we go back to what we know is what we're given in the problem. So if I grab my green here and I say, well, we have 1 hour, that's what we know. And what we're trying to solve for is how many seconds 1 hour is. Again, this is simple math, but it's meant to be simple math just to show you the process. The first thing I do is write down what I know, which is right here, 1 hour. That's the one thing I'm given. Now, I'm going to jump ahead a little bit, and I know my goal is to have my answer in seconds when I get done. So now I set up conversions to cancel the units until I turn everything into seconds. How do I do that? Well, with a conversion. This is a conversion. Let me put hours down here. And I know that I can turn, well, look, we have some conversions here to help us out. It looks like we can turn hours into minutes. Now, bear with me. I know that some of you know these things, and I'm just trying to show you the process here. But it says 60 minutes is 1 hour. Well, that's good. And these cancel. But before I cancel that, look, this looks like what we talked about on the last screen. These are those conversions that we're using to cancel units, because hours and hours are on opposite sides of the line. And math tells us that those two things are going to cancel because they're on opposite sides of the line. Okay, well now I have minutes is the only units I see up here. I don't want my answer in minutes, so guess what we need to do? Set up conversions to cancel the units. Okay, let's do another conversion here then. Let's put minutes down here. And it looks like we can turn minutes into seconds. We have a conversion. There is a relationship between them. And that means that there are 60 seconds in 1 minute. Minutes cancels. That's the whole point of this canceling units part down here. And look, the only thing we have left up here are seconds. That's what we want our answer in. So now it's just a matter of calculating or solving the problem. Now, how do we do that? We use the calculator. We have 1 hour. Okay, so we take 1 hour times 60 minutes. I'm going to hit enter here. Now, I'm going to show you other ways to do this, but I'm not going to let the calculator mess this up for me. Now, depending on how well you know math, you may understand that, well, look here, there's a 1. Anything divided by 1 at this point is just going to be itself. I'll show you because I'm going to click over here, divided by 1. Now, some of you might be thinking, why are we breaking this up into all the pieces? As we move through chemistry, you're going to find out, well, if I break it up, I'll never ever get it wrong because I don't have to worry about parentheses. So we just took 1 times 60, hit enter, divided by 1, just to show you what it would be. I take that whole answer times 60, times 60. I'm going to hit enter. And I take that whole thing divided by 1, which, stick with me here, I'm not going to be dividing everything by 1 after this because I think most of you understand I don't need to divide it by 1. I don't know why that guy's dividing it by 1 because the guy's just trying to show you. Well, over here on my calculator, it says 3,600 seconds in 1 hour, which indeed we do. But do you see this process here of writing down what we know, canceling units till we get the units we want, and then solving the problem? Now, dimensional analysis never gets any more complicated than what you're looking at right now. It really doesn't. And what we need to learn is what are the complex things in chemistry that help us solve things in chemistry, but the 3 steps will never change. Let's expand on this just a little bit. We write down what we know. Notice this is just a little bit different. We're going to go through the same process. Nothing ever changes. Now we have 1 year. I'm not really sure why that's an arrow, but that's kind of cool. I'll leave it as an arrow. And we're trying to turn that into seconds. So we write down what we know. That's step 1. Now we have 1 year. When we get done, and I like to put my goal way over here because it helps me decide what should my conversions look like to get to my end goal. And we need a conversion factor, conversions, to cancel the units. And the only way to get rid of years, because I don't want years in my answer, the only way to get rid of years is to put years down here. Okay? That's why we're putting it there. Then we say, well, what can we turn years into to get closer to seconds? Well, I do know that this is where the problem solving comes in. And dimensional analysis is really problem solving. I don't know how many minutes in a year, but I do know perhaps how many days in a year. Like There are, and I'm going to round this off, 365 days in 1 year. Some of you might know it's far more specific than that, but let's just go with this number because we're just learning a process. Then if I stop right now, my answer would be in days, but I want my answer in seconds. So this is not what I want my answer in. The only thing I can do is get rid of days. So I'll put days down here. And then what can I turn days into that gets closer to seconds? Well, I could turn it into hours because that's a smaller unit. And I know there are 24 hours in 1 day. I don't have any conversions for these. I'm just taking that from my brain because I remember it from life. I need some room here. Let's keep going with our conversions because we have hours right now. So let's do another conversion with hours down here. And do you remember from the last slide that there's a relationship between hours and seconds? Like 1 hour was 3,600 seconds. Let's cancel these units. And look, the only units we have left in our problem are seconds. That's what we want our answer in. Let me make some room. And then we just type it into the calculator. I want to show you something. The last one, I broke it up into pieces and I divided by 1 and times by 1. That's not necessary. So let's just look at this the realistic way that I would type this into my calculator. Clear. We've got 1 year times 365. I always hit enter because I don't need the calculator during order of operations in a way I don't want it. And at this moment, then we're right here, okay? Let's take all of that times 24, times 24. Enter, because why not? Then I take everything up to that point times 3,600 and I hit enter. And there's my answer. 3,153,600. 31,536,000 seconds in 1 year. Okay, notice this is just the process of dimensional analysis. We're using things we understand, and we're going to keep building up to more realistic chemistry things. So stick with me. Look at this. If a car is traveling at 60 miles per hour, how many feet per second is the car traveling? So we've identified our unknown, or what we're trying to solve for, and we're given 60 miles per hour. And we have to be really careful as we write down what we know or what we're given. We have 60 miles, MI is miles, per hour. Notice how I'm writing this because we're doing dimensional analysis, so everything needs to look like those conversion factors that we've been practicing with. Miles per hour. I can put a 1 here because really we're saying 60 miles per 1 hour, but you don't have to put a 1 there. That's up to you. Let's write the goal way over here. I don't know how much room I'm going to need, but I'll go ahead and put, I want it in feet on the top and seconds on the bottom. Let's go back and look. Right now I have miles on the top. I want to turn it into feet. I have hours on the bottom. I want to turn it into seconds. The only way to do that is set up conversions to cancel the units. It doesn't matter which one of these I try to change first. I just pick one. If I put miles down here, I know it'll cancel off those miles. And I need to get rid of miles because I'm trying to turn it into feet. Then I need to decide, do I know anything? Is there any conversion or any relationship with miles? Well, I added some down here just to help us out. And I can turn miles into feet because there are 5,280 feet in 1 mile. Sorry for the poor writing. I just know I'm going to need a lot of space. Look, these cancel. That's what we're trying to do. And feet up here is left on the top, and that's what I want my answer in. So I'm not going to mess up the feet anymore. I'm going to go after these hours because I need to turn those into seconds. Another conversion factor. Well, did you know you can put hours way over here and it'll still cancel hours over there? Yeah. Now I just figure, is there anything I can turn hours into to get closer to seconds? I sure can. We've learned through the last few slides that there is a relationship between hours and seconds, and there are 3,600 seconds in 1 hour, and this will cancel this, and I have seconds way over here. And now I just plug this into the calculator to get my answer in feet per second. We have 60 miles per hour times 5,280. I'm going to hit enter. I'm not going to divide it by 1 because it's unnecessary to do that. Then if I look at the next part, it says I have an answer for everything right here. I times that answer by 1 divided by 3,600. Now anything times 1 is itself. So I'm not going to times it by 1. I'm going to take the answer that's currently on my calculator and divide that whole thing by 3,600 seconds. I'm doing this because honestly, I'm just trying to shortcut it. As we move along in chemistry, we're going to find out some of these problems are massive. There's just multiple conversions and they go on and on and on. And so anytime we can save ourselves a little bit of time and a little bit of work, we're going to appreciate that in the long run. Now, we get 88 feet per second is the whole goal here. Now let's go back to the calculator and let me show you something. If you're not comfortable with this or you haven't learned it this way, you can always take these and put them in parentheses and then put them into the calculator and you'll get the same answer as us. So let me show you how we would do this with the parentheses instead of breaking it up. It really depends on whatever your comfort level is. Parentheses, 60 divided by 1 parenthesis times parenthesis 5280 divided by 1 parenthesis times parenthesis 1 divided by 3600 parenthesis enter. 88. Either way works perfectly fine. The trouble is when you start to get into scientific notation and bigger numbers in your conversions, if you forget to do a parenthesis, it'll be wrong or it could be wrong. So decide what works best for you. You'll see me do it the way that I do it and the way I show my students, but you can always add parentheses and make it your own. At this point, I would encourage you to pause the video and try this problem on your own. I think you can do it. At least you can get it started. Then flip the video back on after you've tried it, and maybe you have an answer or maybe you got stuck, and then see where you end up. The very best way to learn is to do these on your own. I'm going to give you the framework. I'm going to help you. I'm going to teach you how. But if you don't try any of them on your own, it's going to be really, really hard to do this without me sitting here helping you out. So we've got our unknown is hourly cost. That's going to be dollars per hour. Well, what are we starting with? It looks like we have 123.45 or $123.45. And this was in March. So the question becomes, well, how do we deal with this? It's $123.45 per, I'm going to put per March, but let's talk about that. What we really need to figure out is we probably need to get this into days and whatever, and then get it into hours. So we need to know, well, how many days in March, and it's probably easiest to just troubleshoot our way through and call this, let's call it month. For the conversions, I do not want to get rid of dollars, right? That's at the top over here. So because I don't want to get rid of dollars, I'm not going to have a conversion with dollars on the bottom to cancel this out. Instead, I'm going to focus on the months because if I look over here, I don't want month in my answer. So I'm going to put month on the top, knowing that it will cancel this out. Then I think, what gets me closer to hours? What's a smaller increment than month? We just talked about it. Days is probably a good one. And we said, just so happens there are 31 days in this 1 month, this month being March. I'll put days up here because I have to have days on the top to cancel that days on the bottom. And I do know a conversion between days and hours because there are 24 hours in 1 day. So let's cancel these. And look, right now we have we have dollars on the top, we have hours on the bottom, and that's what I wanted my answer in. $123.45 divided by 31 days, enter, divided by 24 hours gives me 17 cents per hour to heat my home in the month of March. Again, this is nothing to do with chemistry, but dimensional analysis transcends chemistry. It's a useful tool in everyday life as well. And as we expand on that, we start to get into things that are more science related. For example, the speed of light and converting that into miles per hour. That's just dimensional analysis, right? That's what we've been learning. And we might not be at the point that we can do that yet, but that's actually where I'm headed with you. In the next video, we're going to really look at dimensional analysis, but first we need to understand metrics, how to convert metrics, and then we can bring that back in with dimensional analysis and we can solve for just about anything we want in science. So watch the next video. Let's keep learning together. Go to bealscience.com and you can watch all these videos and a whole bunch of experiments, or go to bealscienceschool.com and learn more about chemistry and other things. And what I hope for you is that you remember to keep on learning.